Good morning, students. In the previous class, we started periodic properties. Okay, I think what are meant by periodic properties we discussed, and I hope you already written in the notes. What is meant by periodic properties? The properties of the elements which changes regularly along the group as well as period also. Okay, along the group means in which direction? Regarding the groups, we observe the properties from top to bottom. Okay. Regarding the period, we will observe from left to right. Okay. So what are the periodic properties are there? Let us discuss in detail. Okay. Now coming to the first one, a very important periodic property, that is atomic radius. Okay. The first periodic property is atomic radius. Here, this periodic property, the atomic radius is a very important periodic property, because the next coming periodic properties will be interlinked with the atomic radius. Okay. To know how the properties are changing in the group, means whether they are increasing or decreasing, okay, will be related to the atomic radius. Okay, how it is related, everything we will discuss in further topics. So first let us discuss clearly about atomic radius. It will be very easy for me to say simply atomic radius increases in the groups and decreases in the periods. Okay, but we need to know first, what is atomic radius? How we will measure it? Or what are the factors which affects the atomic radius? Okay, we can say simply it is increasing in the groups. So we should know the reason why it is increasing. Okay, because if we by heart like increasing, decreasing, so in the examination we will be confused. Instead of increasing, you may choose decreasing. Okay, so that's why we have to know the reason for all these periodic properties. Right? Now coming to our first atomic radius. What is meant by atomic radius? As we all know, in simple words, atomic radius means in the mathematics, in the lower classes, every one of us knows that for a circle, radius means what? The distance from the center. Right? Now coming to the radius of an atom, nothing but atomic radius means it is the distance between the distance from the center of the nucleus to the outermost orbit of an atom. Okay? So we can define the atomic radius as it is the distance from the center of the nucleus to the outermost orbit of an atom. Note down in the notes. It is the distance from center of the nucleus to the outermost orbit. Outermost orbit of an atom. Okay, the distance from the nucleus to the outermost orbit of an atom is known as the radius of the atom. Nothing but we call simply it as atomic radius. Right? But coming to finding the radius of an atom, it is a very difficult task to find the exact radius of the atom, because according to the quantum mechanical model of an atom, we know that there is no fixed path for the revolving electron. Okay, according to Bohr, we know there will be fixed orbits, but later on what we have found, the electron will be revolves around the nucleus like a wave. We can find only the probability of finding the electron, not the exact location, right? In the answer Heisenberg uncertainty principle also we discussed it. Got it? Okay. So because of that one, we can find the approximate radius of the atom. Okay, we cannot find the exact value of the radius of the atom because here outside the nucleus there is a no limited boundary to measure the length. Okay, because we know the size of the atom. Is it visible? No. Okay, so even there is a no particular boundary for the atom. Right? Got the point or not? So around the nucleus, what we say that there we can find only the probability of finding the electron. So that's why we cannot find the exact distance between center to the outermost orbit. Okay? Then how can we calculate the atomic radius? Okay? Practically, we are going to calculate the radius of an atom using X-ray diffraction studies. Okay? Remember this point. We are finding the radius of an atom using X-ray diffraction studies. Here, using these X-ray diffraction studies also, we can find the distance between two charged species. Okay? Means for a single individual atom, we cannot find the radius. Then what we can find is between two charged species. Nothing but when two atoms are present together, then using X-ray diffraction technique, you can find the distance between two nuclei. Okay? Why I am telling it as a nucleus? Because nucleus is a positively charged. So using this X-ray diffraction technique, we can find the distance between the two nucleus because both the nucleus or any nucleus of an atom will be positively charged, right? For all the atoms, the nucleus charge is positive only. So when the two atoms are present together, then you can find the distance between the nucleus of the two atoms. Then, if I want to find the atomic radius, I can take it off. Is it right? Got it or not? When the two atoms are close together, using this X-ray diffraction technique, we can find the distance between the two nuclei. Now, if I take the half of the distance, we can get the radius of the two atoms. Okay? Got the logic or not? So, by this way, we are going to find the atomic radius. Okay? But coming to the atoms, we know that atoms, some of the atoms like noble gases, if you observe, they don't combine with the other elements. Okay? They will be present like individual atoms. Or if you observe the metals, in the metallic state, only metal atoms will be present. But coming to non-metals, if you take hydrogen and chlorine, fluorine, can you have a hydrogen atom in the nature? No. Hydrogen exists in the nature as H2 molecule, nitrogen exists as N2, oxygen exists as O2. Okay? So individual atoms does not exist. So based on their availability, so we are going to find the atomic radius. Okay? Even the atomic radius will be affected not only by nature of bonding. Okay, here covalent bond will be present. In case of metals, metallic bond will be present. In case of noble gases, van der Waals forces of attraction is present. Okay, so nature of bonding definitely affects the atomic radius. Even there are many other factors like oxidation states or the number of bonds formed between the two atoms. Okay, so there are many factors are there. So based on that, so first of all, let us discuss about the types of atomic radius. Okay. Keep the subheading as types of atomic radius. Based on the nature of the bonding, there are mainly 4 types of atomic radius is there. So let us discuss about the types of atomic radius. Now first coming to the first type of radius, that is covalent radius. Okay, so from the name it is clear, covalent. As we all know how covalent bond will be formed. We all learned in the lower classes that how covalent bond will be formed means it is because of the mutual sharing of pair of the electrons, right? Covalent bond means mutual sharing of pair of electrons. We all know that. So here maybe the 2 electrons will be present. These electrons will be mutually shared between the 2 atoms. Now, in the case of these covalently bonded atoms, for example, H2 molecule I have taken. This is one hydrogen atom, this is another hydrogen atom. Now, this is overall, this is a H2 molecule. So, both are hydrogen atoms. For example, using X-ray diffraction studies, what we can measure? We can measure only the distance between the 2 nuclei. Okay? Now, radius means what? We have to, there is only the option. We can take half of the internuclear distance. Okay? This is called as internuclear distance. So we can take only half of the internuclear distance. Okay? So practically is it correct atomic radius? No, because atomic radius means from this point to this point. But in the case of covalently bonded ones, we can find only the approximate value of the atomic radius by taking the internuclear distance between 2 covalently bonded atoms. Okay? Mainly in the case of non-metals, we will measure the covalent radius. So first note on the definition for covalent radius. It is the internuclear it is 1/2 of internuclear distance between, okay, half of the internuclear distance between the 2 covalently bonded identical atoms. Okay? I think understand the definition. So whatever we learned here, whatever you understood, that was written as a definition. Okay? It is not a new thing. It is the 1/2 of the internuclear distance between 2 covalently bonded identical atoms. Okay? I hope you understood why I have taken as identical. Because instead of H2, if I take HCl, means one atom is hydrogen, another atom is chlorine. So 2 different atoms if you take, one may have large size, the other one may have small size. So even you cannot get the atomic radius of both atoms. So that is why while measuring the covalent radius of the non-metals, we have to take the identical atoms. So not in the way of like this. Okay? So that's where the definition I mentioned is half of the internuclear distance between two covalently bonded atoms which are identical. Right? ನೋಡಿ. Now coming to the second type. Metallic radius or it is also known as crystal radius. A very easy one, from the name we can identify. Okay, so this type of radius is the radius measured in the case of metals. Okay, the metals generally will be in the crystalline state, so that is why it is mentioned as metallic radius or crystal radius. And in the case of this metallic radius, very clear, it is measured in the case of two metals. Okay, so when you take a metal crystal, generally if you take iron rod, now we know that iron metal is full of iron atoms. Okay, they will be arranged in a particular arrangement. Now in that arrangement, same half of the internuclear distance. Okay, so if you measure the radius in the case of metals, so it is called as a metallic radius. Okay, so whatever the type of radius it is simply the half of the internuclear distance. Now coming to the definition wise, how can we define this metallic radius? So metallic radius is nothing but it is one half of the internuclear distance between the two metals in a metal crystal. Okay, two metals means somebody get doubt. For example, some metals may be in the cube shape. Okay, the types of metal crystals, everything in the solid state lesson we will discuss. Generally, we know about the cube. Cube means there will be 8 corners. Okay, so between which two metals we have to take? So that is why in the definition we have to mention one point. That is, we are going to take the metals which are present adjacent together. Okay, because one metal from this corner, one metal from other corner, if you take, you will get more metallic radius. Okay, so which two metals we have to choose means in that metallic crystal, the two metal atoms which are present adjacent, okay, sideways, are the closest metals, right? Now coming to the definition, it is the one half of internuclear distance between, okay, this is the one half of the internuclear distance between two adjacent metals in a metal crystal. Okay, generally we know metals will be in the solid state. So when they are in the solid state, nothing but metal crystal means it is in the solid state. Between the two adjacent metals, we are going to take half of the internuclear distance. Okay. Now coming to the third type. van der Waals radius. Van der Waals, we know it is the name of the scientist, and we know about van der Waals forces of attraction. Okay, between any type of species, or even the positive or negative means we know there will be attractions. Between the neutrally charged species also there will be some attractions, which are very weak attractions, usually known as van der Waals forces of attraction. Okay. Mainly coming to the noble gases, we know there won't be bonds between noble gases. Okay, if you take a helium gas, there won't be any bond between two helium atoms, right? There won't be covalent bond, there won't be ionic bond. They will be present like individual atoms. Now, in the case of those individual atoms also, when they are in the solid state, we know those two atoms will be closer together, and compared to gaseous state, we know in the case of solid state all the atoms are very closely packed together. Okay, so in that solid state, now the half of the internuclear distance between two adjacent atoms, okay, so is known as van der Waals radius. Mainly this radius we are used to find to calculate the atomic radius of noble gases. Okay. Note down the definition. It is the half of the or one half of the internuclear distance between two adjacent non-bonded identical atoms. Two non-bonded. There is no bond, no covalent bond, no ionic bond, nothing is there. Between the two non-bonded identical atoms in the solid state. Okay? So that is known as van der Waals radius. Okay? So there is one more radius, that is ionic radius. But before the discussion about the ionic radius, now let us compare the radius of these three types. Okay? For a particular atom, imagine if we measure the atomic radius, which atomic radius will get highest length? Okay? Very clear, we discussed in the case of atomic radius. If you observe the diagrams, we have already written in the notes. Once observe the diagrams. In this case, definitely the atomic radius is whatever we are measuring is more than the practical one. Okay? In case of covalent one, covalent radius, if you observe the diagram, what we discussed, in that case the practically measured value is less than the actual atomic radius. Right? So if you compare the atomic radius, which one will be highest? Very clearly, van der Waals radius is bigger than metallic radius than covalent radius. Okay? So highlight this one because this was asked previously in the competitive exams. So mention it clearly in the notes. Van der Waals radius write in a simple way. Van der Waals radius is greater than metallic radius greater than covalent radius. Okay? van der Waals radius is greater than metallic radius than covalent radius. Okay. So out of it, the lowest value is for covalent radius, highest value is for van der Waals radius. Right. So these are the main three types of atomic radius. Now coming to the fourth one, that is metallic ionic radius. So that is different from these three. Okay. In what way it is different, let us discuss. So first copy this. Now, coming to the next one, ionic radius. Simply, from the heading, it is clear. We are going to measure the radius in the case of ionically bonded ones. Okay? So, before going to discuss about ionic radius, first we should have clarity about what is meant by ionic bond. Okay? Simply in the lower class, I know every one of you learned that ionic bond. What do we say simply? We may say it is due to transfer of bond. Okay? Covalent bond means we say mutual sharing. In this case, we say it is a transfer of bond. Is it right? No. If you observe the definition of an ionic bond, so first of all, regarding this bond, there is no sharing of electrons. Okay? So there will be no such type of strong relation between these two. So if you observe here, there will be only attractions between a positive one and a negative one. Okay? Because we know there will be transfer of electrons. Ionic bond will be formed due to transfer of electrons. Okay? But that is not the definition. Right? Ionic bond case, we know one atom loses electron, the other one gains electron. The one which is lost the electron is cation, the one which is gained the electron is anion. Okay? Now, in this case, after losing electron, the charge of the cation is positive, the other ion is negative. Okay? As everyone knows that opposite charges attract each other. In the same manner, there will be attractions between the positive charge and negative charge. So these electrostatic forces of attraction between a cation and an anion is known as ionic radius. Sorry, ionic bond. Now the distance between these two ions is known as ionic. Sorry, half of that distance is known as ionic radius. Right? I hope you understood what is meant by ionic bond first of all. Ionic bond means it is the electrostatic forces of attractions between a cation and an anion. Okay? Or a positively charged ion and a negatively charged ion. Anyway, in the chemical bonding lesson, you will get all the data related to ionic bond and all. So just simply I explained. Now coming to ionic radius means what? It is half of the internuclear distance between these ions. Okay? But if you observe there will be two oppositely charged ions. So both are not identical ions. Okay? So in the case of ions, we will measure like this, but it is not the atomic radius value of a particular atom. Okay? Because when compared to the size of the atom, size of the ion is different. So first let us discuss about that. Let us discuss first about the size of the atom to the size of the ion. Okay? For example, this is atom, this is a cation. So means what, it lost one electron. Okay. So let it be its atomic number is 10 for understanding purpose. So if its atomic number is 10, it contains 10 protons, 10 electrons, because in the atom number of protons is equals to number of electrons. Coming to here, we know atomic number there is no change, but the number of electrons is one less compared to the atom. Okay. So if I take the anion, still the atomic number will be same, but now it gained one more electron. So total electrons in this is 11. Okay. Now my question is all the three will have same size, nothing but same radius? Is they will have same radius or not? Definitely these three don't have same size. Okay? That's the logical. First of all, these three don't have same size. Why they don't have same size? People may think, sir, here less electrons are there, here more electrons are there, so that is why this is big size. Okay? But maybe practically by looking at these values, you may think that this number is higher, so it is a large size, this number is less, so small size. But that is not the correct logic. Here, the size of the atom will be depends mainly on the charge of the nucleus also. Okay? The size of the atom depends on the charge on the nucleus. Nothing but we call it as a nuclear charge. If the nuclear charge is more, what it will do? What is the charge of the nucleus? We know charge of the nucleus is positive and the charge of the electron is negative. Right? What positive will do? It attracts the negative towards it. Okay? Now regarding this nucleus, if it has more positive charge, okay, when the nuclear charge is more, what it will do? It attracts the electrons very strongly towards it. Okay, when it is attracting very strongly towards it, what happens? Electrons will come somewhat closer to the nucleus. So radius of the nucleus, radius of the atom will be decreases. Okay. To a very small extent, electron won't come very close to the nucleus. Okay? When it is attracting strongly, definitely it will come somewhat closer. I think while playing, we all may experience this one practically. Right? Let us observe it. In the case of this atom, number of positives, number of negatives are in same number. Okay? So, the atom is having some radius. Okay? Now coming to this cation, what is the difference here? Protons number means number of positives are more, nothing but nuclear charge is more compared to the negative charge. Then what happens? When this side strength is more, so it will pull the other side towards it. Same concept. So because of high nuclear charge in the case of cation, it attracts the electrons very strongly towards it. So that is why the electron cloud will be moves somewhat closer to the nucleus. So that is why atomic size decreases. Automatically atomic radius also decreases. Okay. Now coming to the third case. If you observe this third case, in this case, it is quite opposite to the cation, because here the amount of negative charge is more. Compared to this one, the nuclear charge is less on the electrons. Right? You understand that? You understood this one or not? In this case, positive character is more, so that is it is attracting very strongly electrons. But coming to here, compared to the negative charge, the nuclear charge is less. Okay? So when this side less energy is there, so it cannot pull the other side strongly towards it. In that case, the electrons will be loosely packed. So the electron that is why the atomic size increases, the radius also increases. Got? Understood this point or not? From this example, you have to understand one concept. In the case of atom, amount of positive negative charges are same. Because of the nuclear power or nuclear charge, atom is having some radius. But coming to the cation, what happened here? Nuclear power is more. So because of that strong nuclear charge, it pulls the electron cloud towards it. So size of the atom decreases. What about in the case of anion? In the case of anion, nuclear charge is less. So that's why electron cloud will be moved somewhat away from the nucleus. So size of the atom increases. Atomic radius also increases. Okay? So this comparison is very important because in previous year questions based on this concept, many times they ask, okay, including statewide as well as national exams also, right? So first, if you understand the concept, then we will discuss some questions based on this. So what is the conclusion we can make from this example? The size of anion, is greater than parent atom than cation. Okay? The size of the anion is larger than parent atom. Parent atom is the atom. Okay? Than cation. So cation always has a small size. Anion will have large size. Okay? Now let us look at it and let us discuss some examples. Now do the first question. Which of the following has large size? Oxygen plus 1. And the second option is, let us take sulfur. Sulfur plus 2. Sulfur minus 1. Sulfur minus 2. Sulfur plus 2. Okay? Now my question is, which of the following has the large size? We are comparing for a same atom. If it is a different atoms, how to compare, we will discuss further. Now in the case of same atoms, we observe, we all know that the cation is having small size than the anion. So out of that, the large size will be for what? S minus 2 is having more size than S minus 1. Okay? So somebody may get doubt. Sir, out of these two, how can we choose? Because both are anions only. Okay? Check it. Sulfur atomic number how much? Atomic number of sulfur is 16. So it is having 16 protons. But gained to 18 electrons. What about this one? Having 16 protons only, but 1 electron extra, so 17 electrons. Okay? Here, out of these two, here the negative charge is even more, right? So atomic size will be even more compared to this. Now, out of these two, okay, for plus 1 and plus 2, both are cations. We know cation is having small size than anion, but out of the two cations, which is having small size? Check it. Having 16 protons, but last 1 electron. Having 16 protons, but last 2 electrons. So only 14 electrons are there. So if you observe both the two cases, where the nuclear charge is more, okay? So here number of electrons is less. So nuclear charge will be higher on the valence electron. So automatically the electron cloud comes very close compared to this case. So atomic radius decreases. Okay? Sir, I don't want all these things. I want to remember in one statement. Okay? Somebody may understand, if you understand concept, it is a very good thing, very useful to you to solve all the types of questions. Okay? Or instead of all these things, in a simple statement wise, if you want to remember which is having large size, which is having small size, simple thing. In case of cations, first note down in the notes clearly, mention it as a note. In case of cations, okay, as charge increases, positive charge. Cation means positive charge. As charge increases, size decreases. Okay? As charge increases, size decreases. Anion's case, as charge increases, size also increases. Okay? I mentioned as an anion. So don't think about -2 and -1. Forget about the sign. Remember its magnitude of charge is 2. Here the magnitude of charge is 1. Where the magnitude of charge increases, the size of the ion also increases. Okay? This is, but in the case of cations, as the charge increases, size decreases. Okay? Now do this clear. Right? Now, I hope every one of you got idea about size comparison between the cations and the anions. Now, coming to competitive exam point of view, let us discuss one thing. Ionic radius of isoelectronic species. Okay? Ionic radius of isoelectronic species. We already discussed about this word. Isoelectronic means having same number of electrons. Right? So in such cases, what about the size comparison? Already in the atomic structure lesson, I given the order of the list of isoelectronic species. Two sets of a series of isoelectronic I given. Let us check this one. For example, let us check these two. Okay? So first of all, whether these two are isoelectronic or not. Let us check this. So nitrogen, atomic number 7. So 7 protons, gained 3. So number of electrons is 10. Coming to sodium, atomic number 11. So 11 protons, but last 1. So contains 10 electrons. So having same number of electrons. So these two are definitely isoelectronic species. Now my question is what? We are going to compare the radius of these two species. Okay? I hope you got the answer. You don't go simply like anion cation comparison. Okay? Observe the charge. Nuclear charge, if you see, nuclear charge is very less compared to the next case. When nuclear charge is more, it attracts the electrons very strongly towards it. So that is why the size of sodium is less than nitride ion. Okay? Because in this case, less nuclear charge. So nucleus cannot attract the electrons cloud strongly towards it. So it will move somewhat away from the nucleus. So radius will be more. Okay? But in the case of this one, nuclear charge is more comparatively. So automatically it attracts the electrons strongly towards it. So the distance between them will be decreases. Okay? So remember this. I hope from the anion cation point of view we already discussed about it. Right? Now, let's look at another example. The other example let us see. Sulfide ion. What is its atomic number? 16. So 16 protons gained 2 more, 18 electrons. Atomic number 19. Last one electron, so 18 electrons. Number of electrons is same. So both these two are isoelectronic. Okay. Now, if I ask which is large in size, I hope it is very clearly that sulfide ion is larger in size compared to potassium ion. Okay? Because of less nuclear charge, larger is the size. Higher the nuclear charge, smaller the size. Okay? Now, let us write the order of the radius in the case of those two sets of isoelectronic species. Because 99% or 100% if you observe any previous year questions, you will get the question from these two sets of isoelectronic. Okay? Nitride is larger in size compared to oxide ion, GaN fluoride, GaN sodium. Okay? Don't try to by heart the order. We all know the reason why this is larger in size than this one. Okay? In atomic number 13, all these contains 10 electrons only. Okay? We already discussed previously. Now 13 protons are there. Now here 7 protons only attracting the 10 electrons. Okay? So nucleus and the electron cloud distance is more, so size is more. What is the other set of isoelectronic species? Okay, so this can be. Okay, so regarding the ionic radius comparison of this isoelectronic species, you will get question mainly out of these ions only. Okay, even if they ask any new one, how to answer, we already discussed with reason. Okay, if I give these two sets and if I say it is to by heart, it is a very foolish thing. So that is why this ion is bigger than the other. We already discussed. Now you should be in the position to answer for any type of question. Right? First of this. So till now, we discussed about the types of atomic radius. Now, how the atomic radius changes along the groups and periods we will discuss in the next class. Okay, thank you.